I know, that was really lame. All right. I need to learn to take my phone and put it away because people keep sending me all these reminds and it's blowing up my phone. I feel popular for once. It's pretty great. I just did a hair flip just to let you know. Um, so number 3 is different. Remember how I recorded a video with a special case? Well, number 3, use a highlighter. Number 3 is a special case. So I would put some kind of star next to it because you're probably going to need it on sometime at your daily practice. Speaking of your daily practice, I realized I'm going to have to make the key, which means I'm going to have to scan it off my phone. So I'm going to make it today. It'll be up by tomorrow. At least that's the hope. So bear with me. That one might take a little bit of time. Okay, so I'm going to make room. So I'm going to put first step over here. So I'm going to warn you, we're going to have to do this twice, plus an extra step. So I'm just going to write 1 to tell you we're integrating my parts on the first time. So lie, start there. This is an exponential. This is a trig function. It's like I'm dyslexic today. Okay, so we got to go through and do this. So we got to figure out what u is, du, dv, and v. I'll make my little line. Because I can see Mesa saying you forgot it and then yelling at me at the computer screen. Okay, so u will be the cosine of x. And dv is going to be the e to the x, and then take the dx with it. You're going to integrate, sorry, you're not going to integrate, you're going to derive the cosine of x, which gives you negative sine of x dx, ran out of room, and you integrate this, and it's just e to the x. Now let's talk about these functions as a whole. When you integrate or derive e to the x, it's just e to the x. It's the same thing, okay? When you integrate or derive cosine, it switches between cosine to sine, back to cosine, back to sine, back to cosine. So it's just like this weird effect. When you have both of them, it causes an even weirder effect. So we have to keep that in mind that if e to the x and cosine or e to the x and sine are going to be together, we're going to have some weird crap going on. Okay, so e or u to v and then v to du. I feel like I'm like speaking French or something. I don't even know French, so I'm not. All right, so we're going to take cosine of x times e to the x. I'm going to end up writing the e to the x first because that's just the way it is written. I don't like. And then e to the x, I'm going to put this in parentheses as negative sign so I can be careful with that sign and not think I'm subtracting. D to the x, or dx, not d to the x. Oh. All right, so this is going to get simplified. I'm going to rewrite some things because I just don't like the way they look. Negative and a negative will get me a positive, and then you have e to the x sine of x dx. All right, so we're back to kind of what we had, but now we have a sine function. So now we have to do this a second time. Lucky us, right? So this has to be done a second time. So we're going to go through this process, do it again, because we can, and we will. Okay. I'm going to go like this to separate it. Move that up a little bit to make sure I have enough room. All right, and we're going to go ahead and do this a second time, which is fine. We can do that. We can handle it. All right, we have u, we have du, we have dv, we have v, and our equal signs, and our line. Goodness. Okay, so the question is what is u and what is dv? Well, once again, this is exponential. This is trig, no different than the first. So trig is going to be first, or going to be our u, because it comes before the exponential. One letter before it. So we have sine of x, not the dx, sorry. Sine of x, and then the dv is going to be e to the x dx. Well, that one's easy to integrate, so I'm just going to go right to it. Okay. The derivative of sine of x is cosine of x, and then we'll write the dx because we integrated with that. And then we're going to have to drop some things down. So right here, that was our first, actually I'm going to color code this. Our first step's going to be pink. Second step is going to be blue. So that was part of the first step. That has to follow, and we have to rewrite that. Now we're integrating this blue. So that's part of this step too. That was like really horribly done, but it's okay. So we're dropping down the pink. And then we're integrating this following the blue. So it's sine of x times e to the x. I'm going to write the e to the x first just this time, kind of like here, but I just rewrote it right away. Minus e to the x cosine of x dx. Well, okay. So hopefully you're writing this down and you're noticing something. That's an S that doesn't look like it. You're noticing something. And hopefully that's something that you're noticing is that this right here in the integral is exactly what we started with. So this is where the special case comes in. Okay, so this is where the special case comes in. We'll just make it it's fine. We'll just do it. Okay, so we have this. Okay, but what we have to think about, and I kind of try to make a hint of this in the last video, is I had said at some point with an answer, this integral equals this answer. Well, this integral equals all of this. So what we really have right now, and this is where the special case, this is why I put a star, is we have e to the x cosine of x dx equals all of this right here. E to the x cosine of x plus e to the x sine of x minus the integral of e to the x cosine of x dx. Now I can't say throw it back because you'll laugh in TikTok videos. I'm showing my age, so let's do a throwback. See how I didn't say it that way? Throwback to Algebra 1 and combining like terms. Okay, so, we have like x and 2x, and we add it together, and that's 3x. Okay, well, fast forward, and now we're in calculus, and our combining like terms is a whole lot different. And what I'm hoping you realize is that you have something you can combine. This and this are exactly the same, so you can combine them. To think this at some point was difficult, and now you're doing all of this, isn't it just impressive? Just pat yourself on the back. Just do it. You're doing great things. So you're going to add over the e to the x cosine of x dx. Now when you add that over to here, you're going to have two of them, right? And it equals this. What's the whole point of what we're trying to do? I can see some smart aleck comment from somebody over here. Okay, we're trying to find what the integral is of this yellow crap right here that I want to highlight. Right? We're trying to find this integral. Oh, that was bad. That was real bad. Okay, that was better. So we want this integral to equal something that's useful. Well, we only have to do one more thing. Divide by 2. It's literally that simple. So we're going to divide by 2. I'm going to multiply by a half, just so I don't have fractions involved, like one big fraction. So I'm going to multiply by 1 over 2, which cancels out. So I get 1 over 2, all of this, and you can distribute that through. That is entirely up to you. Some teachers might make you. With our situation, I'm not going to. And the one thing you always have to add is the plus c. And that's done. Okay, that problem is tedious, and it's weird, and it's difficult. So I definitely expect questions on that. But just refer back to this. This is a good piece of information. Okay, I'm going to do number 4, and then I'm going to break it off, and then we're going to do another video. Okay, so number 4, first step you need to figure out is what type of functions you're dealing with. This is algebraic. This is logarithmic. Okay, so this is our 4th example. All I want you to do right here, right now, is to figure out what the u is, what the dv is, and then derive the u and integrate the dv. I want you to do that on your own. You should be able to. I believe in you. Don't freak out. But you need to try to do it now, so when you are out completely on your own, you're good to go. So go ahead and pause the video now. All right, now that you have brought me back, let's go ahead and jump into this. We need to figure out the u and the du and the dv and the v. Okay. Logarithmic, it's the first letter. So your u should be I wrote log. Natural log of x. And the derivative of natural log of x is 1 over x. Okay? And then we write the dx because we derived with respect to x. And then du is whatever you're left with, so it's the x cubed dx, so that's all taken care of for. Everything's accounted for. And if you integrate that, you're going to get 1/4 x to the 4th, and you don't need to write anything after that. So just ignore that little line. All right, and then we have to do our little weird crossy x thing. let's use green this time. Oh my gosh, I suck at this. And we're going to go through. Now, I did tell you in the beginning, if there's a variable left, then you're probably going to have to do this twice. Obviously, there's always exceptions, okay? The x4 and the x will simplify, so you don't actually have to worry about this x. You're not going to have to do this twice. So do natural log times 1/4 x to the 4th. I'm going to rewrite that at some point, but I'm not going to now, so you don't get mad at me. Minus, and then 1/4 x to the 4th times 1 over x dx. Okay, so the x to the 4th is going to simplify with the x over here, leaving us with a 3. I'm going to rewrite this. I'm going to put the 1/4 x to the 4th natural log of x, so they don't ever think that this is part of the natural log. I'm going to kick the 1/4 out, and you have x cubed dx. So that's all you're going to do. You're going to integrate it. So I want you to integrate the rest and see what you get. Work on that scale. So go ahead and pause the video now. All right. Hopefully you integrated it. You feel confident. You will end up getting 1/4 x to the 4th natural log of x. We're just rewriting that. Minus, we're going to add a 1 here, which makes it 4, which means you're going to multiply by the reciprocal of that, which is 1/4. So you really have 1/16. U to the 4th. I wrote U. Did not mean to write that. 1/16 x to the 4th, and always plus c. So that is our final answer. Okay. Hey, it helped me out here. Okay. So I'm going to stop the video here. I'm going to do the last two examples on the other video, right, to help break it up.